Hello, everybody, and welcome back to another Mystery Box Function Challenge. We're up to number 25. Inside this purple box is some mystery math. Some function is hiding in there. It's going to change the numbers that you put in the top into something different when they come out the bottom. You'll get a chart of your ins and outs. You'll even get those graphed as ordered pairs so you can see the shape that this mystery math makes. And your job is to figure out what's inside that mystery box. What's the math going on in there? There's a link in the description. You can click that and get to this page to put in as many numbers as you want to try to figure this out. So pause the video, give that a try, then come on back and see if it comes out like it comes out for me. All right, well, here we go. Here's 0. And we've got, whoa, okay, so this is a strange one. I don't think we've ever had this before. We've got infinity, which does not show up on our graph. Our graph is not big enough quite to get to infinity. Okay, well, that's a weird one. Let's put in a 1. Okay, so 1 gives us 1, which seems pretty ordinary, like f of x equals x. That line could be, maybe there's just something funky with 0 in this one. Let's put in a 2. So if it's, f of x equals x, we should put in a 2 and get out a 2. Let's try that. Oh, so we got 0.5 or 1/2. Well, isn't that interesting? Let's try a 3. And that's a lot of 3s after the decimal point. So that looks like 1/3. Have you got any hunches about this one? Have you got any interesting ideas right now percolating in your brain? I don't want to say what mine is yet. I want to try some negative numbers. I'm going to put in a -1. I think I'm going to get a -1 out of this. Okay. I'll let you in on my idea in just a minute. I want to try a -2, and what I think I'm going to get is a -0.5. Aha. And if we put in a -3, we get a -1/3. Okay, so I think I know what this is, and we're getting a symmetrical kind of thing, but symmetrical about the origin, right? So it's kind of reflected over this point in the middle. And I notice I'm going to actually write some of these out differently. I'm going to write them as fractions. So when we put in a 2, we get a 1/2, and when we put in a 3, we get a 1/3. And on the negative side, it does the same thing, but just negative. When you put in a -2, you get a -1/2, a -3, you get a -1/3. So what I think it's doing is taking our x value and putting it on the bottom of a fraction. So if I put in a 4, it's going to turn it into a 1/4, right? So that would be my prediction. A 4 should be a 1/4. Let's try that. Aha, so that bore out the prediction. Now, I think it's going to work the other way. And the thing I really want to test is what happens when you put in 1/2. So I think it's going to flip that fraction upside down. And I think a 1/2 is going to transform into a 2. That's my prediction. But let's try that. So here's 1/2. Aha, and there it is, a 2. So how can we write the math for this, taking that x and putting it on the bottom of a fraction? Well, I think what's happening is that we're taking, so f of x, we're taking that x and we're putting it 1/x. And if you're confused about how that works with this one, let me show you. If you had we put in a 1/2, so the 1/2 would go down here. How do you simplify that into a 2? Well, we can multiply the top and the bottom of the fraction by the same thing. So I'm going to multiply by 2/2. That's 1, right? We're multiplying by 1, so we're not really changing anything. Here, 2 times 1/2, that equals 1. And here, 2 times 1 equals 2. 2/1 is 2. So that does work for that. If we were to try 1/3, we should get a 3 out here. So let's test that one. So if we put in 1/3, just in that same way I showed you on the 2, it should work for the 3. So 1/3 should give us a 3. Yes, okay. Look at that interesting curve, and the same curve should be kind of mirrored down here. I think we've got this one. I'm going to go ahead and reveal. Yeah, so f of x equals 1 over x. And the graph of this one is really interesting if you haven't seen it before. And there it is. So as you get closer and closer to 0, the numbers get bigger and bigger and bigger. Why is that? Well, the smaller the fraction here, the bigger it would end up being here. So 1 over some really small number. 1 over 10 is 1/10. 1 over 100 is 1/100th. That's much smaller. So if you have 1 over a million, that's 1/1,000,000th. It's really, really, really small. If you put 1 over 1/10, you're getting a really, really big number out. You're getting a 10 out. If you put 1 over 100, you're getting a really big number out, 100 out. So that's why that shape is like that. It's also why we got this. And technically, I don't think this is right because you can't actually get to infinity. So what I would prefer the computer to say here is that you put in 0 and there's an error or it doesn't compute, because 1 over 0, that can't go. There's no way to divide something into 0 parts. So just a little quirk of the computer that made that say infinity. Well, how did that go for you? I think that's the weirdest one we've had yet. And seeing this pattern of sort of reciprocals of what you put in, that was a difficult thing to do, I think. Well, let me know how it went for you. I'd love to hear. Thanks, everybody.